Okay, are we good? I'm looking for Georgios. There he is. Georgios is in the background. He's manning all the stuff. So welcome to Quarkus Insights. I'm trying to run this by myself. We'll see how that goes. I'm here today with two of my favorite people. We had a talk, let me see, what was that, 2 weeks ago, 3 weeks ago? And at the end, I asked a bunch of questions about microservices and do's and don'ts and best practices and things like that. And some people asked for a follow-on of that. So I went and I found two of my favorite people in the whole entire universe to talk about microservices with me. We go back, how many years have we been talking about this? Oh gosh, since like 2015, 2016. Just conversations between the three of us, although two of us separately. We'll see. So anyway, the two people I have with me first, I have Richardson. He is a long-term IBMer. I worked with him forever in my former IBMer life. Solution architect still. He used to run the now defunct Microservices TV. Many architecture pattern examples, lots of customer engagements, many nightmares.
Lots of fun.
Lots of fun. Okay. And also I have Chris Richardson. I'm so excited. And Chris runs microservices.io. And he turned that into a book, Microservices Patterns. And I hope later today we'll talk a little bit. There's a conference coming up that's all about, he's going to running a track that's all about microservices. So I hope we'll get to Chris. I'll let you talk about that for a little bit. I can stop sharing now. So it's back to us. So that's who I have. I can see Chris. You guys want to say? Look, Max is saying hi.
Hello, Erin. Hello, everyone.
How's it going?
There we go. So what we wanted to talk about today was microservices do's and don'ts. So all of the nightmare stories that we have from way back in the yonder days. There was a new article that came out recently on the news stack. I don't know if either of you two saw it. That was like a revisitation of microservices now that it's been out for like, I think it's a cool 10 years almost. Right? We're just about ready for the next cycle where everybody says microservices are dumb. Right? We're about there.
Wait. I thought we were in the microservices of bad phase already. That's been, yeah. You know, it's like if you tweet, don't use microservices, it's guaranteed to get a high level of engagement on Twitter. It's true. It's totally true. So I had prepared just for our conversation purposes. Go ahead.
I'd put some notes together, and one of them was an arbitrarily rhetorical yet somewhat leading question of what is a microservice then, just because we get into the conversation of, are we doing it for the sake of microservices? Are we doing it to solve a problem? And then you get the philosophical battle of, well, it doesn't check all these boxes, so it's not a microservice, and it's the spirit of the law versus the letter of the law. So
that's right. So in honor of this talk, Chris, I went in. Rick is gonna laugh because these charts are old. When this one first came out, there was a jet in the background. We used to use this a lot. Would you two, skimming this definition quickly, say that this is still the definition of cloud native? Have we changed anything? I don't think cloud native itself has changed much.
To me, it's funny. Cloud native is not one of my favorite terms. As far as I can tell, it means anything you want it to mean, and anything that's cool. But in a sense, it's sort of like, it's kind of like if you're running things on the cloud. There's sort of attributes like that, right?
Right.
But so, it's not a term. I feel it's more a marketing term than a technical term.
I can agree with that. The only thing that always got me with the cloud native definition, especially from people coming from on-prem land where you always had pre-provisioned everything and those everythings ran forever, right? I am fundamentally at my core a product developer. Those things always being the mothership app servers that run forever. Mm-hmm. That's my background, right? So when cloud native happened or came around as a definition and a term people started throwing around, the pieces to me that really popped out was disposability, right? Because that's something that if you're writing for the traditional monolithic app server environment, you do not ever really think about processes going away. Right.
Well, it's like, you just take a machine, right? I mean, you give them cute names and you take care of them, right?
Forever.
I mean, it's so funny. I remember a machine from like I think this was 1989. We had a really cool Sun server and it was called Arrakis. And you could say the source code is on Arrakis.
That's awesome.
Yeah, but yeah, now everything is just disposable, somewhat ephemeral.
Yeah, and for me, that's still, a lot of people still struggle with the ramifications of that when they're thinking about things. Now, we talk a lot still. I wanted to bring this chart up because we still talk about 12 factors, and I wanted to know, Chris and Rick, what your favorites were, or which ones you think are the most misunderstood or misused.
Yeah, these 12 factor things, they're still, I mean, I guess they're still good.
I think they're generally still good. There's still, again, portability is in there, which is my favorite. Disposability is in there, which is good. Having your backing services injected, still good.
Config is my favorite, just based off of deploying and building a lot of things that are things we'll take to production, but then also used in conferences and demos and all these other things. And prior to this, it was like, oh, well, we have to recompile it, or like you have to go jump through hoops and go into the middle of that massive app server to reconfigure it. So being able to parameterize everything and dynamically reconfigure stuff at runtime has always been one of my favorite ones of the 12 factors.
Yeah. No, I mean, the things like that are just sort of, I mean, they're just so necessary, right? And yet, I mean, it's been a while since I've encountered anyone who was not building apps that were configurable. I remember a client maybe back in 2017 that, yeah, they recompiled the source for every environment.
So I have a question then, based on your experiences. Do you guys see people having to, how often do you see dynamic response to config change while things are running versus recycling the disposable instance?
Well, that's really interesting. Actually, everything is interesting. Even
That's my favorite. I love it.
Even though it's still dark here, and it's 12 minutes past 6 in the morning, and I'm still waking up. But it's funny because on the one hand, like having a config server where you can change things, and it magically propagates and it updates the application or service configuration sounds appealing. I always worry about that because you contrast it with the other approach where you basically have to do a sort of rolling restart of your instances. The nice thing about a rolling restart is if you've misconfigured them, they fail, then they won't start up. But the other ones and the rolling restart will be aborted. Whereas if you've and the remaining ones will be healthy, and so you've got your system still available. Whereas if you make you change something incorrectly in a config server, it risks impacting everything simultaneously, which makes me nervous.
Have you, Rick? Have you worked with any customers that tried to use a config server for live reconfiguration, or is it mostly?
More of what we're seeing is less of the live reload from a config server and more of a GitOps oriented rollout type strategy. Now I know that there's a level or a certain architecture where you can have the GitOps the config server populated by a GitOps backend or anything like that, but that's just kind of however many pieces you want there. But most of the time we end up seeing folks using things like Argo CD or the OpenShift GitOps operator, stuff like that to bring stuff in. And so it's a little bit more of the rolling restart that Chris was mentioning, where you're able to catch some of those config errors when things are trying to roll out, as opposed to just playing everything and kind of live dynamically injecting into the running processes where you may not have as much of a level of as many gates as possible as you would with the other kind of more static rollouts.
Cool. From a, how I want to get to some of our big do's and don'ts situations. I don't have like charts for us to talk to. I just tried to throw some things together so we could go back through all of the stuff we've learned over years. So
well, you know, one thing I would throw out is I feel like nothing you've said so far has anything, well, these two slides has anything to do with microservices.
No, not specifically. I wanted to bring these up because they are almost always the backstory. To me, like having these 12 factors especially, but having these as like, this was the point. Like taking advantage of clouds, you know, of cloud environments and being able to respond to this infrastructure that was supposed to be able to dynamically tune itself. And then looking at the 12 factors, which were more designed for SaaS software than specifically for microservices. But when we talk about microservices, we frequently talk about those in the context of 12 factors, right? Valid microservices should follow 12-factor practices so that they can behave responsibly as part of a big distributed system. So I wanted to sort of touch on these background pieces. I think I took, you remember this picture? I drew
Looks
this
familiar.
picture in, I don't know, 16 or something. It's in a book. So this was the microservices piece, at least one of the pieces, Chris. I think you have on your, I'm gonna flip around here because I have from your introduction, I have like you have a whole pattern language defined on microservices IO that talks about, it gives all kinds of examples for how people should stage out microservices patterns or, you know, microservices architectures. But I think if we go to like a simplistic view, this would be a simplistic view. Yeah? No?
Yeah, sure.
Twist his
No,
arm.
I mean, yeah.
In the original days, this is great. Like, this is what I wanted to talk about, is how things have moved, because we do talk about microservices very differently than we did when we started, right? When I was first coming to understand what microservices were, it was always this, let's compose an application of these small independent pieces. And again, for me, like the mind shift, the big hurdle coming from a more traditional environment was the independence of these things, where you really get into independent life cycle, independent ship schedule, independent evolution of each service. I think so many people never actually get there, but that independent part where then they're replaceable, not just because you're scaling, but because literally you could say, well, this service was written in Python and now the performance sucks, so we're going to rewrite it in pick language, right? If you go, Discord has a great article on how they took one of their services, because these services are independent, they took one of their services and rewrote it from Go to Rust because of performance reasons, right? But because their services were independent, they could make that change and do that, and it was something, you know, that they were able to do because they had good boundaries between their services such that they were independent.
Yeah. Well, I find it, yeah. No, I sort of like this, like small. I mean, that there's a lot of nuance behind the definition of it, you know, I guess I was independent, you know, I would say for sure independently deployable, right? I think that's that's kind of a key point. Replaceable is really interesting. It is sort of like kind of a good attribute. It's an interesting thing as to how do you tell whether something is replaceable or not.
Yeah. So
right.
One of the things I see people struggle with, and this is, again, it's like old habits die really hard. So when you have the typical pattern, which is I'm going to run all of these things in staging, and then in pre-prod, and then in prod, and I'm going to roll them all together as a unit, that says to me that your services aren't independent.
Well, that was getting to me as far as what do you mean by replaceable? Is the instance replaceable, or is the capability it's providing replaceable at the same time? Because those are very similar, because like what you were saying, when they all have to move in lockstep, then they're not necessarily independent. And then I would argue that they're not replaceable either. And so those are all the things where it's like, yeah, we're doing microservices, but all you have is a monolith that you just have split across 4 repositories, as opposed to anything that you're doing microservice wise.
Yeah, I mean, I often say, to me, like, replaceable means that you can rewrite it with a different technology stack, which is which might be, I don't know if something's independently deployable, maybe can you get replaceable for free? Right.
Kind of. I think the question is, did you design it in such a way that you do you have like a good isolation encapsulation boundary, right? If things are independent, but the interfaces are really entangled, or you're relying on a language specific communication protocol, then you can't do that easily.
Yeah. Well, I mean, I think actually it's interesting, funny, right? Because I think loosely coupled, to me, that is a key attribute of the microservice architecture, right? And loosely coupled both in a design time coupling sense, because that means that they can change independently of one another, and you've minimized the probability of having to change multiple services in lockstep. And then also runtime coupling, which is more to do with availability. So that's certainly true. The last bullet point, processes.
That one has to do with scaling. And that particular one is the place where you're shifting a mindset from scaling, oh God, what the hell did they say? Vertically? Let me add more heap and more CPU. So you're making the instance fatter to handle the load, versus scaling horizontally, which is just adding more instances.
Yeah. That's an interesting bullet point to have, because you could sort of say, because I was thinking about it in terms of like traditional deployment, right? Where you have a long running process, whether it's running on a virtual machine or it's running in a container, but then there's something like Lambda, AWS Lambda cloud functions, right? That you don't have long running processes.
Right. You would argue that any little tiny given one is a process. So you end up with little transient things, which has huge ramifications on your data management, which is something you two are both working on independently in different ways. You are both working on event-driven systems. We have one question coming in before we move on. And I don't have charts for any event-driven stuff, and that's this one. So how should we explain the difference between microservices and our favorite SOA architecture? Yay. To say architecture after SOA is, I realize, totally redundant. But
well, I think at a very high level, they're all about services. So you could sort of say they're the same. But the path that SOA went seemed to be more around reuse and putting APIs onto large monoliths that were perhaps tightly coupled anyway through databases, and then communicated via an ESB, which had sort of integration logic running in it.
Yeah.
And even the motivations for SOA were it seemed to be about reuse.
I would say, or go ahead, Erin.
Oh, no, you go first.
I was gonna say it's more about like cross-pollination and advertising of services and getting things out there with like the different type of service registries than what's on the screen now, but a lot of the reusing those, and it was kind of even a lot of just putting some front ends in front of some pretty heavy monoliths, and just so those services were available to be consumed by participants in any number of processes or any number of business processes, things like that. So it was more about the reuse of business logic that someone out there was publishing and saying, here, I have this, I can do it for you, as opposed to microservices is really focusing on the way how you build and run something within your team itself.
Yeah, I would describe it using Adrian Cockcroft's words from a long time ago when he used to talk about microservices being about smart endpoints and dumb pipes. For me, SOA was smart pipes. SOA was all about the ESB and doing integration layer and transformation. And yes, it was all about what was advertised in the WSDL, but the pipes were the ones doing all that translation and all that transformation and all that stuff. You had really, really smart pipes to try to accommodate and make different disparate endpoints be all universally able to communicate. And then when you shifted to microservices, it was very much like the endpoints are dumb. They don't do anything, or the pipes are dumb. I mean, like they don't know anything about what's happening. Each service is its own kingdom, its own fiefdom, and it does all the stuff like it's its own unit. It minds it has its own notion of what data is. It keeps things to itself, and that goes with the replaceable concept, where if you have to redo the inside of that service, you can, and nothing else knows. You don't have to go update any other definitions anywhere because nobody else knows what's going on inside the service. And that, to me, was the big difference between SOA and microservices.
Mm-hmm.
Ooh, this is a good question. Just put it up. This is a great question. I love this question. It's big. So we want to put the microservices are autonomous, but it isn't it actually dependent on another API that has to be kept in sync that it consumes and produces for? This is a great question.
Well, so yeah, I think when you're creating a microservice architecture, right? I mean, the number one thing that you have to do is come up with a set of loosely coupled services, right? Almost nothing else matters in compared.
And they should be few. Start with few because you'll get it wrong.
Well, there's a bunch of issues. I mean, granularity is another issue, right? Like you want to find a minimal number of services, and there's a whole bunch of nuance there, but like you could just say we'll have one service per team, right? Per 5 to 9 person, team, Scrum team, or whatever you want to call it. So you want to have a coarse-grained architecture, unless there's a really good reason to have more. But
you'll usually find that reason as you go. So start with less.
Yeah.
Then as you go, you might decide, this should be, you'll discover more, but don't start with more. Start with less.
And interestingly, minor aside, so if you go to microservices.io, there's a pattern which is service per team.
Yes.
But a common anti-pattern that I've seen repeatedly with companies is a service per developer, roughly. Which it's just so common. But anyway, the key point to get to the heart of this question, right, is whatever services you have, they should be loosely coupled from a design time perspective. And design time coupling is really the degree of design time coupling between a pair of services is the likelihood that they have to change in lockstep.
Right.
And the extreme case is if you can have a bunch of services, but because of how you've done the decomposition, every time you change, you need to make a change, implement a new requirement, you have to change all of them in lockstep, you have a distributed monolith, which is really the worst of both worlds, right? So it's the complexity of microservices with the friction of the monolith. So, your goal as an architect is to design your services so that they are loosely coupled. And that gets into issues like having stable APIs that encapsulate as much as possible. So basically, it's sort of like anything that is hidden behind an API can be changed, right?
Right.
So the variable parts of your system need to be encapsulated behind stable APIs.
And then the follow-on to the stable API part, if we're talking about REST APIs, is that those APIs should be versioned.
Yeah.
And then consumers of the API, either looking at data coming in or looking, when you're receiving data, that you ignore stuff you don't understand.
Yes. Well, there's sort of, what your point there is about sort of managing the evolution of API,
right,
which is related but slightly separate in a sense. But what key point I want to make is imagine you're consuming a service like Stripe or Twilio, right?
Mm-hmm.
You are consuming their APIs, so you are dependent upon them. But when was the last time you had to change your application because Stripe changed something or Twilio changed something? And I'm going to say kind of like never, or once in a blue moon, right? Because they have stable, well-designed APIs that encapsulate the details. So like you can send an SMS just by saying, send this message from this phone number to that phone number. And the hideous complexity of doing that at a global scale is sort of hidden from you.
How can I get it? There we go.
There you
Yay.
go. And then, so they've carefully designed it so you can be dependent, but not have to change all the time. But then at the same time, to get to Erin's point, they've put in place an API management evolution sort of management strategy that lets them evolve their APIs without forcing clients to change.
Right. And if you like, there's great APIs that are like, for example, ones that I like to look at or show as examples, like Square has their APIs. You can go peruse like what they look like, how they're structured, and you can in GitHub also. And for both of them, you can see the version is in the URL or it's in the header, an accept header, which means that like in this lockstep thing, this keeping in sync, you don't have to keep in sync because the services that are providing this service, they can see based on the URL requested what the consumer understands. So the consumer can set an accept header that says, I accept this specific version of the API. Not only that, but so the URI could say accept version 2, and an accept header can say, with this feature flag, I understand this thing, which allows the producer to evolve ahead independently of the consumers who might lag behind. And this is one of those areas I wish we had better tools for. It feels like we have a notion of contract testing in the industry, and we don't have a lot of people actually doing it, because like Pact is a great example of how you can have the producer of a service like publishing the API plus example response data to a service. So then consumers can test against a mock that is protected from drift because it's getting the sample responses from the Pact server. But as the consumer tests, it publishes its sample input data. So it's to the Pact server, which means the producer can test against what consumers are using. So it gives you like a decoupled way for the two independently evolving services to maintain their independent life cycles, testing against mocks that have a system in place to guard against drift.
Yeah, I mean, absolutely. I mean, interestingly, I would take a step back and I would say that we've had testing tools for a long time. They're not used as much as they should be. Right? I hate to name drop, but I was hanging out with Kent Beck at this conference a couple of years ago. You know, when you could hang out with people without getting a fatal disease?
Yes. We have had some great times hanging out at conferences. I miss it a lot.
Yeah, it was safe. Maybe 2023. And I said to Kent, it was like, hey, when's, you know, he created JUnit, right? When was that? 1999?
Long time ago.
Yeah. And I said, hey, when do you think this automated testing thing is going to catch on?
It's getting better. I actually think some of the recent CI/CD tool shifts, like I would say the last 5 to 7 years worth of stuff, like once people could run Travis by themselves or Circle CI or now GitHub Actions, like any of that stuff, for me, for even my personal screw around projects, which of course that's what I do most of the time. I make screw around projects that make no sense to anybody but me. I then like running tests that will run in that automated pipeline, because then when I make a PR to myself, because I do that, I can make sure I'm not going to break a few, like 6 other people that care about what I did. And it just runs. So while I am really dubious about code coverage for some languages as being a useless metric, I do actually really like testing. And I like that it's easier now for me going into automated pipelines to take advantage of that. It makes my tests worth writing because they just run.
Lowers the barrier to entry to be able to do what you want to do, as opposed to needing to architect that whole piece in addition to what you're trying to run the tests on. You're just
and it makes it easier for me to get value from writing them.
Yep.
I would like to think that things have improved, but I'm not sure how great. Really well.
I was going to say, you brought up
I'll give you an example of this. It's interesting. Source Labs, they had a state of testing report, right? But the only one I can remember, the most recent one I can remember, was 2018. And essentially what they found was 72% of companies were relying extensively on manual testing.
Yeah, I think we still have a lot of manual testing in the more complicated cases too.
2% of companies were fully automated. And as I said, JUnit's been around for a long time.
Yeah, I think we still have gaps, like this contract testing gap. I know not a lot of people know how to do that. And that's like beyond the boundaries of a single service. Like I think a lot of people write automated tests for this one service or the one product or the one component within their product if they're working on a product. They'll do automated tests for that thing. What we don't have a good system for yet that people like there's Sauce Labs and stuff for like the end user stuff, but that the outside in view or the more complicated across component or the contract testing layer, like that, I think is where people are still really struggling for how to set up those environments so that it does run in an automated way. That's part of why I like packed testing. I just wish it were more common and in some ways easier to consume. I found when I used packed myself, it was too easy to get lost and retest the mocks on the wrong side. Like you have to remember which mock you need to be like. I'm on the consumer side. I don't need to retest some of this stuff because I'm testing the mock that came from the producer. I need to just focus on my stuff and the rest happens. It just meant like it was really. It's like once you get into that test mindset, it was just really easy to kind of wander off into exhaustively testing stuff I didn't need to test because it was
further down the spiral.
Yeah, but the thing with packed is and contract testing is that it allows what I know, how to test a unit to be useful in testing across units.
Yeah. Well, I think it goes back to one of the essential characteristics of the microservice architecture, right, is that the services are independently deployable. And
right.
Arguably, if you have to run an end-to-end test in order to deploy a service, it's not independently deployable.
Yes.
And so, yeah, each service has its own deployment pipeline, and then that deployment pipeline should just deploy into production at that point.
Yeah, Cindy Streetham has a really good set of articles about testing in production, which gives a lot of people who are used to monolithic code environments heartburn. They're like, what? You tested what? How do you no? And it's
yeah. Well, let's just say I remember some people have said you could call it validation in production. It sounds less
less terrifying.
Yeah, but I mean, the funny thing is, it's a very disciplined technique, right? Yeah. And so it works. I think one of the challenges is if you think about acceptance tests, right? One of the, like, imagine a user story. As a customer, I want to place an order, blah, 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 right? And you have acceptance tests derived from that. They tend to verify, they tend to span multiple services, right? So your acceptance tests very naturally map into, testing is interesting, come on. They tend to map across multiple services, and so they naturally map to end-to-end tests, right? Whereas you actually have to reformulate your traditional acceptance tests into per service tests,
right?
Go down the test pyramid, so to speak. And I think that's a challenge for organizations.
Yeah. For sure.
I want to follow up on this point. I want to rant now. I'm warmed up.
I woke up now.
So I would argue that testing is just part of development, right?
Yeah, it is.
Like if you're not testing when you're developing, then what is developing? Just simply typing code in and compiling it, and then you're done.
Yeah.
Right.
Yeah. So,
and I'd add a corollary on my soapbox for documentation there too. I know developers never want to write documentation, but if you're the only one that can use it, then it's not really doing that much. So if it's not tested and nobody can discover it or understand it, then you may as well just be monkeys on a keyboard.
You're just creating the tree in the woods that falls down and nobody knows.
Exactly.
Testing can be your doc. So for me, we have another couple comments about testing. So I have made my career, huge parts of my career, throwing away code I wrote or rewriting it because requirements changed. And I will say that I have a knee-jerk hate of code coverage because I've seen people write, and again, this is partly just Java because there's code paths that are absolutely stupid to test. And when people go for 100% green code coverage, they write stupid tests, just dumb, stupid tests. And for me, it has been critically important to have really good tests that verify expected and required behavior. This has to happen. And if this comes in, this comes out. Very rarely at the boundary of a method. Like I remember in the old Eclipse tools, if you wanted to create a JUnit test, it would be like, here, let me generate the test for you for each method. Those are worthless. They are absolutely worthless. Because when it comes time to refactor something because requirements changed or the model doesn't work or you have to restructure whatever, if you have to change that many of your tests, you no longer know that your code worked. And you can't refactor it and still be confident that you didn't break something important. So that code coverage isn't bad if you focus on the right areas and ignore the useless bits. That is like super highlighted, right? It's like you can't safely refactor if you don't have good tests that test the important characteristics of your behavior to make sure that those are sane. And when you map that onto contract testing, which is what we've kind of been talking about for how to make sure that your service satisfies the expectations of consumers, that becomes a behavior driven. The consumers they're giving you this input and they're expecting this back. That's the contract that you have with this other team. And you are establishing, as the producer of a service, you are establishing what behavior they can expect. And that becomes and how that contract can evolve safely, how those things can, do you have it versioned right? And the things like that packed server will show you the versions of the API that you're testing against, so that you as the producer, for example, can recognize, if I make this change, I'm breaking their expectations. I have to increment the version. I have to change something about the version so that I don't break the existing consumers. That way I can release because there's a feature flag or I have it guarded. And if I don't see this, then that way they're not broken. They can opt into the new behavior over time because they will see my change in packed. They can start consuming it, right? And so you have the independent evolution and you have the independent deployment, but people can see what's happening and can evolve with a little more safety. But I don't see many people like really grokking how to do that. It's such a struggle. So you two have been working on events a lot. And like, I can visualize very easily how to do this with REST, how to version REST API, how to manage like how your requests come in and out. How does that work when you're dealing with events and event structure and event data? Like, doesn't that, how do services that are dependent on event content evolve? How does that work?
Yeah.
It's the concerned look on his face. Yeah, that's hard.
Yeah. Well, I'm gathering my thoughts.
I mean, I would say it doesn't venture too far from your last mini rant, Erin, as far as versioning and as far as versioning the body of what's coming in and understanding that. It's just how are we capturing that? How are we working with that in an event space? And most of what we're doing lately has been centered around schema registries and the use of that for what we're building and kind of running. And there's a number of them out there now. And they're kind of growing and evolving in their capability as well. But that is there's a lot there for controlling forward and backward compatibility and everything. But that's also understanding when you're able to control the entirety of kind of the event spec as well. So there's a number of, like you were saying, if you're working with an underlying infrastructure provider and those events, they're more probably to be like the Stripe or Square ones that are evolving less. But you still have to understand those and capture those and version those in addition to whatever you're creating internally. And so most of what we've been doing for that has been focusing on integrating schema registries with the rest of the components and in either operating your own schema registry and making that similar to the pack server, or using a third-party schema registry that's hosted and run as a service somewhere.
Do you use schema registries, Chris? Do you see those?
Well, I was going to sort of answer it differently, the question differently. I mean, I look at, events, so how can you evolve them, right? I mean, so on the one hand, kind of changing events in sort of backwards compatible, additive ways is pretty straightforward, right? So you can add attributes to an event and then consumers can ignore it, right? If they're not interested in it.
Right. And that's a REST pattern too, is to ignore the stuff you don't understand, so you're not fragile.
Yeah. I mean, that's Postal's law in action, right? So that those kinds of changes are pretty straightforward. What the harder problem is sort of breaking changes in a sense, right? Where, say with a REST API, the client can say, I understand version 2, even though you're on version 3 in the server. can handle that. Whereas so with events, there's the consumer doesn't get to say that. The producer just publishes. And so there are some really interesting issues around, well, how does the producer support version 2 and version 3 simultaneously, right? And I guess it could publish events to different channels, or
is that what you usually see? Do you see different topics, or
what? Say that again.
Do you start seeing different topics then?
Well, you could, yeah. So that's a channel. I mean, abstractly, topic.
Yeah.
Abstractly, that's a message channel. Yeah, you could version that way, or it could publish multiple versions of the same event to the same channel, and then just have the consumers filter by event version. So there's a few ways to do it. There's sort of deeper. You can kind of view it as like there's the technical aspects of event versioning, and then there's the sort of the semantics, the deeper meaning of it, right? Like it's kind of, when you think about an order life cycle, order created, order, approved, order shipped, and so on. What does it mean to change those events, make a breaking change to those events? Because that's so tied into the essence of what an order is, right?
Right.
And maybe in a lot of scenarios, the domain of this, the events are so tied back to the domain that they tend to just be fairly stable.
Well, that's what I was going to get into. Another kind of philosophical / semantic question of, like, if we were talking about what are we defining microservices as, because are we saying a single deployment of a Kafka connector could be a microservice, or is a microservice? Like, what exactly does that make it a microservice, or how are we managing it? How are we deploying it? How are we monitoring it? All of that stuff. So that's kind of the lead-in question. But then some of that, you can do a lot of, single message transforms inside of a Kafka connector to pull stuff into Kafka that would inherently change a lot of that internal messaging that could break eventing in the future and version there. So that kind of goes into there, is like, what stage of are you versioning? Are you versioning the internal pieces? Do you have another piece that now deploys to it or publishes to another topic? Like, how are those things? And so you have both the lower level pieces and then the higher level pieces of what does it mean to version and evolve and kind of keep up with the different changes, both breaking and non-breaking in your eventing infrastructure.
So there was a notion with REST, how long ago was that? I don't remember, where there was kind of a recommendation that someone creating a REST API should also create a client library for consuming it. It wasn't a requirement, but it was like a recommendation, right? Because REST is just JSON, so anybody should be able to do it. But would it be considered good or normal to have to publish the consumer, like a consumer library for events? Would that handle the versioning? I'm trying to think of the smart endpoints, dumb pipes comment, right? The more you put closer to the Kafka connector, the more it starts to feel to me like SOA and ESB. Because the ESB is, the Kafka is starting to get too smart.
Mm-hmm.
If you had, which might be fine. I'm not judging. I'm just saying it feels like we're going.
But the connector is existing outside of the pipe, so it's kind of it's functioning in its own space, and it's working to connect some of those systems. So it's not necessarily embedding it in Kafka itself, because you could write a number of things to inject stuff into the backbone.
Yeah, I guess it's still a better. Yeah, I guess the deployment of an ESB was a pretty big monster in and of itself. So yeah, I can see that. But if I had a client library for consuming my events, would that make it easier?
I feel like the short answer to that is no.
Good. Okay.
Well, you sort of have, because, right, you got a bunch of clients out there, and you know, are they using different versions of the client library of client libraries, right?
Well, they would be, for sure.
Right, exactly. So I don't think client libraries are sort of, they're a convenience that enable just sort of, I don't know, simplify the development of clients, but I don't think they solve any key problems with versioning.
Yeah, but they could abstract or hide some of the specifics of what's on the wire.
But you're in that implementation style, you're basically creating schema registries with more code and more distribution and more tight coupling.
Yeah. All right.
Yeah,
that's fair.
They're not solving the essence of the problem.
All right, so don't do that.
You got to don't.
Yeah, one thing I want to throw out, it's so funny because I actually have to go in 1 minute. So this is the most excellent time to throw it out. I think this was 2018. I gave a talk and the title was "There's No Such Thing as a Microservice." and what I meant by that is there is the microservice architecture. There's an architectural style for structuring your application as a set of services. But a single microservice in isolation is not a meaningful concept.
Right. Right. Yeah, it doesn't mean anything.
And I've been wanting to throw that out for a while because it's because I think it kind of properly describes the kind of what the microservice architecture is.
Yeah. No,
absolutely.
So on that note, I need to go.
That's fine. Thank you for coming. I will put out, well, you were coming and I'm here. It was going to be fun. Come on now.
Yeah.
So this conference, before you go, oops, I'm on the wrong screen. This one is when? November?
Yes. Oh, yes. I'm reading the slide. It says November the 1st to the 12th.
Yeah. So you're leading this particular track, which is super relevant to this conversation. And I know you're having my other long-term super best friend, Holly Cummins, coming to talk. Yes. She is also super amazing. So I'm excited about that.
Yeah. So this is a virtual online conference. It's funny, actually, I don't know the details about registering for it or anything like that, because I've been so focused on tracking down speakers, right? And all I know is, it's in November sometime. So the microservices track is going to have 3 most excellent speakers. And as the track title suggests, it's really, the focus is on trying to get case studies. So, true lessons learned talks. And so there's 3 tracks, and then there's a live panel discussion as well.
Awesome.
So it will be fantastic. And the other thing I would say is QCon is actually my favorite conference. It's such a high quality conference. I've been going to various QCons around the world since I think 2009 or something. It's just been forever, and I love the conference. So I'm super excited about being involved in it.
Cool. All right. Well, thank you for coming. I know you have to escape, but I appreciate your time.
I know. I have to go teach a class in 2 minutes.
Yay!
So. All right.
I'll catch up with you later.
All right. Talk later. Bye.
Great talking to you.
All right. Rick and I aren't going anywhere, though. All right. So
I'll put a plug for this, though, because I brainstormed some notes over the weekend on some of the stuff we had talked about last week, and both, a lot of client stuff we've done together in the past and separate things we've talked about. So I had like a list of like 5 or 6 things. And then since I knew Chris was coming on, I just hopped on microservices.io, and on his anti-patterns page, all of what I had written down for my notes over the weekend, he has in one slide there. So, I mean, it was good that we're all talking the same thing, but it was basically like all of the bullet points are right there. So it was like, oh, I could just use his stuff for reference too, because it's the same exact issues we hit with all of our client stuff. So yeah, it was just, it was odd serendipity that it happened to be almost bullet for bullet point.
Well, so if you remember when we were working on the Architecture Center for IBM, I wanted to collaborate with Chris. I wanted Chris to come in and do stuff. And that was a bazillion years. That was like dinosaur years ago, it feels like. I do super enjoy Chris's company. I don't laugh. Well, you too. But anyway, I collect people that make me laugh until I can't breathe. And both of you fit that bill. So that's good.
Yeah, most of our conversations are
good.
half talking, half laughing hysterically. So
yes. So the one other thing, oh wait, I'll bring this back up. I had one other trip down memory lane that I wanted to throw out, and I kind of brought it up a few times and then we didn't really get to it. So these books came out 1,006 years ago. Actually, the first one isn't a book. That's Martin Fowler's Microservices page. And I think anybody that hasn't read it, they should. Sam Newman, I know, is coming out with a revised version of his Building Microservices page, which brings in learnings then of the past 10 years. So that one is one to look for. And we've already mentioned domain-driven design here about like what, 6 or 7 times. So if you guys if anyone in the audience is working with microservices or trying to migrate patterns, microservices.io has the patterns for microservices, but I don't know if you agree with me, Rick, but domain-driven design is huge.
Yeah, I mean, we use that relatively regularly with all of our event-driven stuff as well. So I mean, so it's super broad, but then also it can be very applicable for specific implementation patterns and things like that. So it's a very fruitful book and concept and domain area, pardon the pun, to dive back into.
Yeah, I am challenged when it comes to, I don't know how I made it through my CS degree because I really hate reading books like that. It's just very dry. There's a few other domain-driven design books that are like, here, let me digest this for you and show it in a different way. But I actually found like certain sections of Eric's book to be like a good read for putting together in your mind when we talk about small, or when you talk like what that air quotes small is, or when we talk about what a good encapsulation boundary is, or how you should think about breaking down a system. I found the concepts in his book to be really useful for getting your brain in the right place to be able to have that conversation. And like, I know you were like my shirt. We wrote the text-based adventure game that we wrote 1 million years ago. It ended up like pointing out some of the things that Eric talks about in his book by accident. And some of them are concepts that I think a lot of people would benefit knowing, like what a universal language is and why that's important when you're working with different teams who are all collaborating on like the different services that need to comprise one system, and how important it is that they're all actually using the same nouns and verbs to mean the same things, and how easy it is for that not to happen because English language actually secretly has a shortage of nouns.
Well, and how easy it is to then make your APIs be less volatile when you're using that universal language, as opposed to redefining the same thing multiple times across different teams providing similar APIs, et cetera, et cetera.
Yeah. And then Release It. I don't know if you have, Release It was old, right? And that was trying to get people into the DevOps mindset. I don't know if you have newer ones that you would recommend.
It's actually in some of the research and reading that I've done, as I'm staring at another 60-page Gartner doc on my desk that I have to get to. So I'm similar to you, where it's not going to grok getting into my brain sometime soon. But like I read one last week, and they were still referencing Release It as a reference. So I don't know if there was a version or addition to reference to that. But it's still pretty common, and it's one that it's always like, oh yeah, I should read that one, and then I never get back to it. So that's one that's still been on my radar for a while, but I know it's still pretty relevant in a lot of the terms, especially now with the influx, I would say probably in the last 18 months of GitOps getting into kind of the zeitgeist of all of the conversation, and it being another way to interact with CI/CD and pushing code and all of this stuff. So that's one that's definitely on my radar.
Yeah, and our Georgios tells me from off stage that it has a second edition too. So yeah, so that one, those were the 4 that I looked at in 2016, and I think all of them are still must reads if you're in this space. So now if I look at some of the other comments we have, like if we go, I did it right, Georgios, I figured out what button to hit. Yay. It's like this one is when you have reactive services communicating with another reactive service, that does not mean that you have reactive behavior throughout your system. Would you say that that's true?
Yeah, I mean, I would say that's true, going back to all of what we've talked about so far, because there's still a lot there where even if the service itself is operating in a reactive manner, there's still lots more on the fringe that could break that. And again, the contract testing and some of that stuff. So needing to understand more of it, and there's more compensating behavior that you would want to build in there for when things break and restart and some of that. So it's having the reactive nature for each of the individual services is a great start, but then it's still kind of, you still need more there to be able to have the reactive system as a whole.
Right, you need like to be working off of Kafka rather than working off of REST. Like you need to be in a place where you are all responding to events. So I could work with a REST API and make sure that everything within my service is written reactively so that I'm not blocking within my service, so that I'm doing non-blocking behavior, right? But then there's a different thing for how you create your whole system so that everything is event driven. And that's a flip from blocking technologies. What do you see when people are trying to do like flip over to event-driven systems? For me, the stumbling block is always data.
Yeah, and I mean that's why I kind of brought in no, I know you're excited, but this isn't your question. That's where going into like the Kafka connector piece, and everybody say hi to Ollie.
Hi, Ollie.
He's going to get down now and run away. But that's where the Kafka Connect piece comes in, because where you end up having a lot of implicit integration with the event bus and being able to pull some of that information in. So there's many kind of evolutionary strategies for that, but I would generally say like you can bring in the eventing as a side effect at first, and then start to get everybody ramped up and see what's there, and then eventually shift over people away from the REST API to the eventing API, and you can interact in that manner. And so we've used Kafka Connect in that way to be able to pull things such as change data capture and things like that, so that we're pulling things from existing systems and getting some of our consumers into the event-oriented way. And then once we know that the mass of the gravity is there, we'll start to kind of shut down the original systems or scale down the original systems and roll that way. So there's a lot of ways where we can kind of step by step move folks over from one REST way into event-driven, event-oriented, more reactive thinking.
Cool. All right, so it is a little past the top of the hour, which is when we wrap. I hope everybody that was watching, I didn't get any questions from Max. Max said hi and then he vanished. So I'm super disappointed in Max. He was supposed to ask questions. But I hope everyone enjoyed this. If you want to send in questions or find me on Twitter or I don't know, find any of us on Quarkus dev list or in Zulip and say, we would like to see a demonstration of, I don't know, whatever, or we would like another session that explores this, please let us know. I hope this was entertaining, minimally, maybe informative. I don't know. But thank you all for watching and participating. I know you guys had I saw some chats where you guys were talking back and forth, which is super good. And I think once, Georgios, you're going to have to come off screen. I'm going to put you on here for a second. I'm going to pop you in. Ha! Okay. When is the next one? We're Wednesday next week. Do you know?
I think it's next Wednesday. Yeah.
All right. Okay. So we will see you all next Wednesday. Do you remember what the topic is? Because I don't.
Yeah, we have a contributor, Paul from South Africa. He's going to come on and tell us a story about how his company adopted Quarkus and how they're succeeding with it.
Woohoo! Cool.
At least that's what I remember. I mean, unless I've completely confused the shows, but I think it's correct.
I think that sounds roughly right. I'm pretty sure it's next Wednesday. So we will do that, and we'll see you all next week. And meanwhile, please give us feedback and send us suggestions for more topics. And I don't remember, do we push which button? Georgios, you push buttons. We'll see you.
See ya.
Bye, everybody. Thanks a lot.